This is Unit 5, Day 5, starting out with a quadratic formula. It's really important that you guys follow along and read here. It says, we saw in Common Core algebra, so 2 years ago, how to solve a quadratic equation by completing the square. For those who forgot, here's your procedure. So not only did you see it in algebra course, but we also did it this year. I'm not going to take the time to read through all the steps again because we've already taught it this year. But the only thing I want to draw your attention to is step 3 here. We don't always say 1/2 times b quantity squared. We sometimes say b over 2 quantity squared. Okay, some of you know the saying, half it, square it, add it. Alright, so this next example here, it says solve the following quadratic equation by completing the square. Put your answer in simplest radical form. So that means you have to reduce your radicals. So step 1 is to isolate the x terms. So you have to bring over your c to the other side. So it becomes x squared minus 6x equals -1. Now this is my b, so I have to half it. I get -3. Then I have to square it. Don't forget it's in parentheses when it's a negative number. And now I have to add it to both sides. So half it, square it, add it. So I get x squared minus 6x plus 9. And what I do to one side, I have to do to the other. Now if you remember factoring that, it becomes, well, what multiplies to positive 9 but adds to -6? And that's going to be a -3, because -3 times -3 is positive 9. But when I add them, I get -6, and that's equal to 8. Now, before today's lesson, we normally stopped here, and then we would write the vertex of the parabola. So the vertex of this quadratic, its minimum would be at +3, +8. But from here, you're now going to say to yourself, well, how do I get rid of a squared? I take the square root. And what you do to one side, you have to do the other. Now, taking the square root of something squared just removes the square. But then don't forget, anytime you take the square root, it's positive and negative of that square root. Last step, I have to isolate this x right here by adding 3 to both sides. And I'm going to get x equals 3 plus or minus the square root of 8. And because the direction said keep it in simplest radical form, I have to break down the square root of 8. Okay, so that means my answer is x is equal to 3 plus or minus 2 radical 2. Remember, x could be 3 plus 2 radical 2. That's one root. And the other root is x could be 3 minus 2 radical 2. Alright, so this next thing is talking about the quadratic formula, and again, you've also learned this in the Common Core algebra sheet, but I want to remind you, even though it's on the reference sheet, you do still have to know when is it appropriate to use it and how do I apply it, okay? So we already know our answer is going to be 3 plus or minus the square root of 2 radical 2, but let's try it using the quadratic formula. So my a is 1, my b is -6, and my c is -1. Okay? So x is equal to the opposite of b, so just put in +6, plus or minus the square root of. Now your b is -6, so make sure you keep it in parentheses. So when you square it, you get the correct answer. And then it's going to be -4 times a times my c. Oops, I'm sorry, c is not -1, c is +1. Okay, all over 2 times my a. So just simplifying, doing some math. Use your calculator to help you out. I usually go now simplify things underneath the radical. So -6 squared is 36, and it's going to become -4 all over 2. So it's going to be 6 plus or minus the square root of 32 all over 2. You're going to break down 32 to square root of 16 times the square root of 2. So that means x is equal to 6 plus or minus 4 radical 2 over 2. Now, train your brain, get in the habit of GCFing the numerator. So look at that numerator only and decide what you can divide out of your 6 and your 4, and you're going to know that that's a 2. So when I divide the 6 by 2, I'm left with 3 plus or minus 2 radical 2. And those numbers should be a little familiar. The last step is you can now reduce these two on the outside. They cancel each other. So then my answer is x is equal to 3 plus or minus 2 radical 2. And that just proved that we got the same answer as the previous example. Example 25. Now, you have an option. I'm a really big fan of completing the square as long as the a is 1, so the number in front of x squared is 1, and I know I have to take b divided by 2 and square it and add it, so if it's divisible by 2, it makes life easier. If not, use the quadratic formula. So you have the option to complete the square or quad form. I like completing the square. To me, it's a little bit quicker. But quadratic formula will never fail you to work on all factoring. Okay, so I'm going to get negative 20. Now, ready? I'm going to take my b, negative 10. I'm going to half it. I get negative 5. Negative 5 squared is positive 25. So I'm going to add 25 to both sides. So I get x squared minus 10x plus 25 is equal to 5. And again, that is because negative 20 plus a 25 on that side is going to be a positive 5. All right, now when I factor that, it's going to become x minus 5 quantity squared equals 5. I take the square root of both sides, and I get x minus 5 is equal to plus or minus the square root of 5. Last step, I have to get this x by itself, so I'm going to add 5 to both sides. So I move that over there, and I get x is equal to 5 plus or minus the square root of 5, which is choice 4. Okay? Example 26, the zero product law. When you see zero product law, that just simply means to factor. Okay, that just means go ahead and factor that. So you have a couple options here. You could use guess and check. Okay, so you're going to say, you know, what multiplies to this, and you got to kind of foil it in your head and see what comes up when you have your binomial times your binomial. You could use slip and slide, or you could use the AC method. Okay, or if you're really good and you know what's going on, you can use your polyroots in your calculator. All right, so I'm going to do a little slip and slide review. So I slide out the 2. I'm left with x squared plus 11x minus 12. Factor old school. Don't forget to keep that equals 0 the whole time. And I know that if I have a plus 12 and a minus 1, I'd get positive 11. I slip the 2 back in front. Okay, split. Oops, not yet. Don't split. Now divide both of these by 2. Okay, you don't write that anywhere. You just do it. So you're going to get x plus 6 and 2x minus 1. And the last step, split, set them equal to 0. So I'm going to get x equals negative 6 and x equals positive a half. So those are my two roots. Okay? Quadratic formula. Now, I already know what my answers are, negative 6 and positive a half, but I'm going to use the quadratic formula. And it's just proving that you should get the same thing. It's just a different method to do it. Okay? I want to remind you guys, quadratic formula can be used on every single thing. So if you would normally use slip and slide, if you normally use guess and check, if you normally use AC method, quadratic formula works on everything. So ready? X equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So just some simplifying here. Again, I usually go to underneath the radical. I know that's going to be 121. And that's going to be a plus 48 all over 4. Okay? So I'm going to get negative 11 plus or minus the square root of 169 all over 4. Now hopefully you recognize that this is a perfect square. So that's 13. So I'm going to get negative 11 plus or minus 13 all over 4. So that means one of my answers is negative 11 plus 13 over 4. And the other answer is negative 11 minus 13 over 4. You can't leave those. You have to simplify it. So negative 11 plus 13 is 2 out of 4. 2 out of 4 is a half. Okay? Negative 11 minus 13 is negative 24. You divide it by 4, you're left with negative 6. So I get the same results that I just received up top, and it didn't matter what method I used. Example 27. Solve each of the following quadratic equations by using the quadratic formula. So you're going to do the same thing again. Okay, please make sure you always realize that this has to be set equal to 0. So sometimes if they throw the c on the other side, you have to move it over. So a is 3, b is 5, c is 2. Okay, So x equals the opposite of b plus or minus the square root of b squared minus 4 times the a times the c all over 2 times a. Okay, so just continuing, simplifying that a little more, and I'm going to end up with negative 5 plus or minus. It ends up being 25 minus 24 all over 6. So that is going to be negative 5 plus or minus the square root of 1 all over 6. The square root of 1 is 1, so I get negative 5 plus or minus 1 all over 6. One of my answers is negative 5 plus 1 over 6, and the other answer is negative 5 minus 1 over 6. And then you just continue and simplify those. So negative 5 plus 1 is negative 4. Negative 4 over 6 simplifies to negative 2/3. There's one of my x's. Okay, over here, negative 5 minus 1 is negative 6. Negative 6 over 1 simplifies to negative 1. So these are my two roots. Okay, part B says 2x squared minus 2x equals 5. Make sure the equation is set equal to 0. So you have to move that back to the other side. You're going to get 2x squared minus 2x minus 5 equals 0. So now, ready? My A is 2, my B is negative 2, and my C is negative 5. So x equals opposite of B, 2 plus or minus. Again, b squared is negative 2, so keep it in parentheses squared, minus 4 times a times my c all over 2 times a. So continuing simplifying that, you're going to get 2 equals plus or minus, and it becomes 4 plus 40 all over 4. So it's 2 plus or minus the square root of 44. Oh, sorry. This down here, I had a mistake there. Over 4. So the square root of 44 breaks down to 4 times 11. So that is going to be 2 plus or minus 2 radical 11 all over 4. Again, I said before, make sure you GCF all numerators. So if you divide out a 2, you're left with 1 plus or minus. You can put that 1 there, but it's really just square root of 11 all over 2. Oh, sorry guys, full of mistakes. All over 4. So now the last thing would be to reduce this. That cancels to 1. That's going to be a 2. So my final answer is going to be 1 plus or minus the square root of 11 all over 2. Okay? Okay, example C. A equals 5, B equals 8, and C is negative 4. So ready? X equals opposite of B, so negative 8 plus or minus the square root of 8 squared minus 4 times my A times my C all over 2 times my A. So X is equal to negative 8 plus or minus the square root of 64 plus 80 all over 10. So X is equal to negative 8 plus or minus the square root of 144 all over 10. Now that's a perfect square, so you're going to end up with negative 8 plus or minus 12 over 10. So 1 is negative 8 plus 12 over 4. I'm sorry, over 10, which is going to be 4 tenths, which reduces to 2/5. The other one is negative 8 minus 12 all over 10, and that's negative 20 over 10, which is negative 2. So there's my other root.